Welcome back to Applied Algebra and Trigonometry. Today we're going to be talking about addition and subtraction of fractions. Okay, addition and subtraction of fractions both require a common denominator. Here is a simple example with arithmetic. Common denominator already. Add the numerators. 5/9 is the answer for this example. This problem, 3/4 minus 5/12, takes a little more time to do because the denominator is not common to both of them. We have 4 and 12. The multiples of 4 are 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. Oh, look at that. We already hit a common multiple because 12 times 1 is 12. Okay, so now we have to convert 3/4 into a fraction that has 12 in the denominator. To do that, we're going to have to multiply that denominator by 3, which means we multiply the numerator by 3. So now we have, instead of 3/4, we have 9/12 minus 5/12 equals 4/12. And we're not quite finished because this can be reduced. 4 goes into 4 once, and 4 goes into 12 3 times. You can think of it that way, or you can think of it as 4 divided by 4 and 12 divided by 4, which leaves us with 1/3 as our answer. That's how we add and subtract fractions arithmetically. Let's move on to fractions in algebra. As long as all of the fractions have that same common denominator, you can add or subtract as many as you want. Simply combine all the like terms in the numerator and keep the denominator the same. If you do not have a common denominator, you will need to find one. You can find multiple common denominators for any denominators that you have, but the easiest, the most useful, is the least or lowest common denominator, also known as the LCD. The LCD will be an expression that is a multiple of every denominator that you are trying to add or subtract. So let's take a look at the possible multiples of 2a and 3b, which are our current denominators. So the multiples of 2a would be, well, 2a, 4a, 5a, but it's not just those multiples. You could say 4b, 5b, 5c. So it can be difficult, especially when you're dealing with an algebraic expression, to just try out multiples until you find one that is a multiple of both of them. Now, this is a rather easy instance, and you can probably see what it should be. But let me show you a different way to think about this. Instead of writing down all of the multiples, let's write down instead first the prime factors of 2a. Well, there's 2 and there's a. Those are the prime factors of 2a. The prime factors of 3b are 3 and b. Every prime factor that shows up in one of the denominators must show up in our common denominator, and it must show up the maximum number of times it shows up in either one of the others. Now, this one's a pretty simple instance in which you have one of each prime factor. Therefore, every one of them has to show up, and the LCD, the least common denominator, equals 2 times a times 3 times b, or 6ab. So now we have our common denominator, but we now need to figure out what each fraction will look like with that common denominator. So let's take our first fraction. We want it to have a denominator of 6ab. What do we multiply 2ab by to get 6ab? Well, 3b. But we must do that in the numerator as well, so that we don't change the value of the fraction. So we have 6ab as our denominator and 3bx as our numerator. So we can rewrite it up here, 3bx over 6ab, And from that, we're going to subtract whatever 2y over 3b looks like when we find an equivalent fraction with the denominator of 6ab. Well, we have to multiply by 2a to do that in the numerator and the denominator. So 4ay is what we get as our new numerator, 4ay over 6ab, and we can now do our subtraction. 3bx minus 4ay over 6ab, and we're done. Now you know the technique. Let's use it on some more challenging problems. Here we have two fractions with different denominators, so let's find our least common denominator. Because I've gone ahead and factored our first denominator, when I rewrote it, I have actually listed the factors. And there are no factors of x plus 2 other than 1 and itself. It is prime. Our least common denominator must incorporate all of the prime factors of all of the denominators. Therefore, this is our least common denominator. So what must we multiply 2 times the quantity x minus 3 by to get our least common denominator? We have to multiply by x plus 2. Means we have to multiply in the numerator of that fraction by x plus 2 also. Similarly, to change 2 over the quantity x plus 2 into an equivalent fraction with our least common denominator, we are going to have to multiply the numerator and the denominator by 2 times the quantity x minus 3, or 4 times x minus 3. So let's write that in over here. We are subtracting that. So here's what we have in the numerator and in the denominator. We have 2 times x minus 3 times x plus 2. With that numerator, we may be able to combine some like terms if we go ahead and distribute to get rid of the parentheses. So let's try that. If I distribute the 5, I'm going to get 5x plus 10. And if I distribute, be careful here, if I distribute the negative 4, let's go ahead and take the negative with it and deal with it all at once. So negative 4x, and now the negative 4 times negative 3 gives us a positive 12. Don't drop the denominator just because we're working mostly in the numerator right now. Now we can combine like terms. That gives us x plus 22 over 2 times x minus 3 times x plus 2. And we are done. It cannot be reduced any further. New problem. I'm going to go ahead and factor these denominators over here before I seek out the least common denominator. The factorization of this trinomial can be rewritten two ways, the way I'm writing it here, or as just the quantity x plus 1 squared. And your least common denominator must have every prime factor from every denominator in it. So 2 shows up once, and x plus 1 shows up. The most it shows up in any one denominator is twice. So there is our least common denominator. Now, what do we need to multiply our first fraction by in order to get it into this form with this denominator? We need to multiply by x plus 1. What should we multiply our second fraction by to get it to have the correct denominator? By 2 in the numerator and in the denominator. So 2 times 2 and 2 times x plus 1 times x plus 1. And now we can go ahead and combine what we have here. But first I'm going to distribute and multiply. So 3x plus 3, and we have a subtraction of 2 times 2 over our common denominator. I'm going to do one more thing. I'm going to combine like terms. And now that I've done that, I see that the numerator does not factor, so there is no chance for us to cancel and simplify. That is my final answer. New problem. This complex fraction will force us to combine our techniques for division, multiplication, addition, and subtraction. So let's do it. let's examine the numerator first. What will the least common denominator be for the numerator? Well, that LCD will be xy. So what do we multiply x over y by to get xy in the denominator? Well, we multiply by x. So we have x squared in the numerator. And what do we multiply y over x by to get xy in the denominator? Well, we have to multiply by y. So we're going to get y squared over xy. Okay, so let's rewrite the numerator first. X squared over xy minus y squared over xy. And then the denominator. What's going to happen to that? In the denominator, remember, anytime you have a whole number, you can rewrite it over 1 and it does not change the value of the number. Well, the other way to look at this is we need to express 1 with a denominator of x. Well, anything divided by itself is equal to x. If you want to do it the way we've been doing it, you can look at it like this. 1 over 1, we need to get to a denominator of x. What do we have to multiply to get there? Multiply by x. So we're going to have x over x plus y over x. So let's combine terms in the numerator and the denominator before we try to get rid of that fraction bar between them. So we're going to have x squared minus y squared over xy. In the denominator, we're going to have x plus y over x. Let's go ahead and convert it now to a multiplication. You could do it in a different order, that's fine. But here I have x squared minus y squared over xy. I'm going to multiply by the reciprocal of our divisor. But now I have something in the numerator of my dividend that can be factored. So I have to do that. X plus y, x minus y is what that factors into. And I have xy, I'm multiplying that by x over x plus y, remembering there are grouping symbols because everything there is in the denominator. X plus y is one term. Because it's one term, now I can cancel. I can also cancel these x's. So what am I left with as my answer? I'm left with x minus y over y. That's it. For this last example, we're not going to work all the way through the addition, or at least I'm not going to. Feel free to work it all the way through yourself. It is non-trivial, but it is not very interesting either, but feel free. What I want to do with this example is to illustrate once again the process of how we we find our least common denominator. So I have rewritten each of the denominators. Let's write out the prime factorization of each of these. All right, I have 2 times 5 times r. I'm going to go ahead and write this out as w times w. This one becomes 5 times r times r times r times w. And our final denominator becomes 3 times 5 times r times w times x. All right, each prime factor that shows up anywhere in those 3 lists has to show up in our least common denominator. So I'm going to write it in a different color so I can keep track. 2 shows up here. Times 3 shows up. Times 5, okay. What is the most number of times 5 shows up here? There's once, okay. And then we have to have r. What's the most number of times r shows up? There's once, there's 3 times. So we want 3 r's in here. And then we go to w. So 2 w's here, 1 w here, 1 w here. We should have 2 w's. That's the most that is found in any one of the denominators. And then I have an x in this denominator. Okay, I'm just going to return to my blue color as I multiply all of those factors to get my least common denominator. That will give me 2 times 3. 6 times 5 is 30. R cubed, W squared, X. That is the least common denominator of those three fractions. And like I said, I'm not going to go through the rest of it. I just wanted to emphasize how to find the least common denominator consistently. So practice your addition, practice your subtraction, practice your factoring, your multiplication, your division of fractions. Just keep going, ask any questions you may have, and I will see you in class.